Hello, this is hopefully shorter than yesterday, a video presentation on factoring where the leading coefficient is prime. When the leading coefficient is prime, we know that one of the first terms of our factors must match that number. So my leading coefficient is 2, I have a 2x here, and an x here. Negative 20, one has to be positive, one has to be negative. Now we have to try our different pairs. So the first thing I'm going to do is write out all the pairs. Well, I'm going to write out the problem first. All right, pairs of factors for 20 are 20 and 1, 10 and 2, 5 and 4, and there is no more. So we're going to have 2x and x, and we know there's no common factor here. Because there is no common factor here, and there never should be, you should factor that out, because there's no common factor here, I can't have a common factor here. So because of that, I can't put a 20 here. I can't put a 10 there. Can't put a 2. Can't put a 4. That would mean I would have a common factor. But there is no common factor. So our choices for the plus and the minus here, our choice is either 1 or 5. I can either put a 1 here or a 5 here. Only choice I have, nothing else, so I don't have to try anything else. Now, let's do our double smiley, and 1 is supposed to be positive. Positive 5x minus 2x, 5x minus 2x is 3x. I wanted 3x, I'm good to go. I didn't have to try all the different possibilities because if I put a 4 here, I would have had a common factor. Had I put a 10 here or a 2, that essentially eliminated this completely. I couldn't put a 20 here. Could have put the 20 here, but not here. So always look at that. Not always going to help you, but many, many times it will. All right, let's look at another example. All right, first thing we look for is common factors. Right off the bat, I see that I have x cubed, x squared, and x, so I know there's a common factor of x. Because all the numbers are even, I know that I have a common factor of at least 2, but in this case, it's a common factor of 4. But let's say you don't realize 4 goes into these. Just do 2. And we end up with 4x squared, 2 times 38x plus 2 times 48. Because they're all, again, even, I know that I didn't get the common factor. Common factor is bigger. There's another factor of 2. So I bring that 2 out here. This makes it 4. And then I have 2x squared minus 19x plus 24. And now I'm going to look at my pairs of factors. 4x. I know I have a 2x because it's prime, and an x. Because this is positive and this is negative, each one of these must be negative. A negative times a negative is positive. So now I'm going to look at the pairs of factors of 24. 24 and 1, 2 and 12, double the 1, cut the 24 in half. Double the 2, cut the 12 in half. Double the 4, cut the 6 in half. And those are all my pairs. Because there's no common factor here, no common factor right there, I can't have a common factor here. Can't do it. So let's look at what we can eliminate. In this spot, we'll use green, in this spot right here, I cannot have a 24, I cannot have a 12, cannot have a 2, that eliminates those, cannot have a 6, cannot have a 4, that eliminates that, cannot have an 8. My only choice then is a 1 or a 3. Now it's not always this easy, but oftentimes it is. So I'm going to put the 3 here, I'm going to put the 8 here, and then I'm going to do my double smiley face and check. That should be a 3. And check and make sure I get negative 19. Minus 16x minus 3x equals minus 19x. I wanted a minus 19x. There's my answer. That's simple. Eliminate the things that can't be, and oftentimes you don't have many other choices. All right, for Monday we are going to look at case 3, when the leading coefficient is not prime. Stay tuned for the next episode in this exciting series. Talk to you later. Have a great day. Love you guys.